Although we've dealt with the structure a little bit here and you've seen some example programs and some instructions, let's take a look at the structure of assembly language. An assembly language program consists of, among other things, a series of lines of assembly language instructions. An assembly language instruction consists of a mnemonic, optionally followed by one or two operands. The operands of the data items being manipulated, and the mnemonics are the commands to the CPU, telling it what to do with those items. An assembly language program is a series of statements or lines which are either assembly language instructions, such as add LW or move WF, or statements called directives. And if we jump forward here a couple of these, we can see from this example, that's exactly what we've seen before. There's our move command, there's our add LW. While instructions tell the CPU what to do, directives, also called the pseudo instructions, give directions to the assembler. While the move WF and the add LW instructions are commands to the CPU, org and end are directives to the assembler, and we've seen those already. The directive org tells the assembler to place the opcode at memory location 0, while the end indicates the end of the source code to the assembler. In other words, one directive is for the start of the program and the other is at the end of the program. An assembly language instruction consists of four fields: the label, the mnemonic, operands, and the comments behind the semicolon. Brackets indicate that a field is optional and not all lines have them. Brackets should not be typed in. Regarding the above format, the following points should be noted. The label field always allows the program to refer to a line of code by name. The label field cannot exceed a certain number of characters. We'd have to check with our assembler to find out what the rules are for the number of characters. The assembly language mnemonic, instruction, and operands fields together perform the real work of the program and accomplish the tasks for which the program was written. In assembly language, statements such as move LW and add LW are your instructions to the CPU. Add LW and move LW are the mnemonics that produce the opcodes. If they were followed by 55H and 67H, then those would be the operands. Instead of a mnemonic and an operand, these two fields could contain assembler pseudo instructions, or what we've seen as the directives. Remember that directives do not generate any machine code or opcode. They're only used by the assembler as opposed to instructions that are translated into the machine. The opcode, or the CPU, then is used by the CPU to execute the program. Commands org and end, origin and end, are examples then of those directives. More of these pseudo instructions will be considered later. The comment field begins with the semicolon comment indicator. Comments may be at the end of a line or on a line by themselves. The assembler ignores comments, but they are indispensable to programmers. Although comments are optional, it's recommended that they be used to describe the program in a way that makes it easier for someone else to read and to understand. And these are really indispensable when you're writing code, because invariably, if you write it, somebody else is going to have to read it and make sense out of it. If we take a look at this example, notice that the label here in the field, in the go-to, the PIC is told to stay in the loop indefinitely. If your system has a monitor program, you do not need this line and it should be deleted from your program. Okay, so we can see that here command at the very bottom. So this is, again, another example of the types of things that we've seen in terms of writing a program in assembly. So next we'll take a look at the assembly and linking a PIC program to an actual device.